Hi, today we will see complex analysis, PHYS course. Okay, let's look at the numbers first. Let's start with complex numbers. We know that if we have like x squared plus 1 equal to 0, the solution of this is not real because x squared will be equal to minus 1 and the solution will be complex because there is no such a number to give you minus 1 when you square it. That's why we make a new definition. We say that the square of I is minus 1, and then you can write this as I squared, okay? X squared is equal to I squared, and here x will be equal to plus and minus I, the solution. So also the square root of minus 1 is just square root of I squared, and it is equal to I. So whenever we end up with square root, which is minus, then it goes out as I. So I is the complex number. Complex number. So all the complex numbers can be written in terms of I like this. So Z is the complex number, which has real and complex part. Okay, Z is given as x plus iy. Okay, x plus iy. X is the real part and y is the imaginary part. Sometimes it's called complex. Imaginary and complex are used for both. Okay, so now, for instance, a real a complex number can be 3 plus I 2, something like that, or 2i. So we can now start by doing some operations between the two complex numbers. One is just if z1 is given by x1 plus I y1 and z2 as x2 plus I y2, then z1 plus z2 will just give you, okay, x1 plus x2 plus I y1 plus y2. As you see, we just add the real parts and imaginary parts independently and get the result. So if it is minus, then we can use the minus signs there. Okay. So if these two complex numbers are equal to each other, x1 and x2 should be equal and y1 should be equal to y2, basically. Okay? So some operations. So the product between the two complex number, okay, z1 and z2 is just the product of x1 plus, okay, I y1 times x2 plus I y2, and you have to do regular multiplications. Okay, just multiplying this one and that, and then this one and this one. So basically we will have 4 terms, and the result will be just given as x1 x2 minus y1 y2. Okay, this is the real part, and the imaginary part is just x1 y1 plus x2 y1. Okay, so this is z1 dot z2. It's not the dot product or something, it's just the multiplication. So you don't have to really memorize these formulas because you can just add them up if the complex numbers are given. And we have another thing, which is division. So if you are dividing z1 by z2, okay, it's just the division of x1 plus I y1 divided by x2 plus I y2. Okay, so we don't really leave it like that because we never want any complex thing on the denominator. So we have to get a real thing, real number or real function if it is given as functions on the denominator. So in order to get the real thing, we have to multiply this by x2 minus I y2. It's the complex conjugate of the denominator So it's just changing the sign of this I term. And then, of course, when you multiply the top by the same thing, nothing changes, right? So we multiply top and the bottom by the complex conjugate of the denominator. So if we do this, okay, so we will get simply x1 plus I y1 times x2 minus I y2 divided by, now let's see what happens, x2 squared, okay, plus y2 squared. The I terms will cancel each other because one is plus, the other is minus, right? So the intermediate terms will cancel each other, and then we will end up with this. But we can still open this up, okay, to write real and imaginary parts separately. Of course, you don't have to memorize again. So the real part is just x1, x2 plus y1, y2 divided by this denominator, x2 squared plus y2 squared. And then the imaginary part is just x2y1 minus x1y2 divided by the same denominator, x2 squared plus y2 squared. So this is z1 divided by z2. So division is slightly complicated, but not really very difficult. Actually, if z is given as x plus I1, I, then z complex conjugate is written as star. Z star is the complex conjugate. It's just x minus iy. X minus iy. That's why if you want to get the magnitude of z, it is given by x squared plus y squared, okay? And then it is the square root of z times z star. So you have to multiply the complex number by its complex conjugate and take the square root, and it will give you the magnitude, or the magnitude of the complex number. Okay, so this is the end of the first recording.